Subject of today's tutorial is the 2+2 cycloaddition process of olefins forming cyclobutane moieties. It is a concerted process. This means that the two new sigma bonds are formed at the same time while we are losing those two pi bonds. According to Woodward and Hoffmann, it is a frontier orbital controlled process which is allowed after photochemical irradiation. So that means we have two ethane molecules which will interact, one in the ground state, the other one in the excited state. What does this mean if we have a look at the orbitals? So for this pi bond, we assume a bonding pi molecular orbital. This is bonding because we have the same phase here. Here is a positive orbital overlap, and therefore this is the bonding pi orbital. Here we have a change in phase, no positive overlap. This means this is an anti-bonding pi molecular orbital. In the ground state, both electrons are in the binding pi orbital. In the excited state, one electron has changed to the anti-bonding pi orbital. So remember, same phase, positive overlap. This means bond formation. And now we can combine the binding orbitals of the two ethane molecules as well as the anti-bonding orbitals. And there are two ways possible. So let us assume we combine here the same phases, then we have bond formation between these centers, while we have the change in hybridization from p orbitals to sp3 hybrid orbitals. So positive overlap, and on the other hand, if we have combined different phases, there is no overlap, and therefore this is the antibonding molecule, an antibonding molecule orbital of the cyclobutane. Here we have a binding orbital, and we have to distribute overall 3 electrons with this combination. So we have 2 electrons in the binding orbital and 1 electron in the anti-binding orbital. Accordingly, we can also combine the anti-bonding orbitals, and we will also then obtain 1 binding and 1 anti-binding molecular orbital of the cyclobutane. We have 1 electron. This will end up, of course, in the bonding molecular orbital. So, after the cyclobutane formation, we will initially have 3 electrons in 2 binding molecular orbitals and 1 in an antibonding molecular orbital. This is, of course, an excited state. To get to the ground state of the cyclobutane molecule, this electron has to change from the antibonding molecular orbital in this binding molecular orbital. But this will set free energy. That means the molecule is in some kind of hot state and has to deliver to get rid of that energy. Otherwise, the retroreaction could take place. So, how can this excited cyclobutane molecule get rid of that energy? Well, just by interacting with other molecules or with the walls of a reaction chamber. So, after it has delivered this excess energy, then we are in the ground state, and in the ground state at moderate temperature, a cyclobutane molecule is completely stable. Thanks for listening.